Hey, Chloe, give me just a minute. I'll get started. I'm just waiting on my babysitter.
Yes, ma'am.
Okay. Hey, don't touch my camera. Woo. Hello? Well, hello everybody. I got my camera up on the board. I got a few things up there. It was more up there, but I have two little ones that erased it, but I am gonna put a few more things up there on the board for you. I know you guys are wondering, what are you putting up there? This is the exam topics. And hold on just a second. I need to actually chart half reactions. Let's see what else. So I'm going to go over the exam topics of what we're going to have for the exam on next week. You guys, the quizzes, did y'all check them to see if they were working? Chloe, chime in. What Canvas told me to do is just take it all out and just reset everything and start back over. And that's what I did. Hopefully that worked. So try it again today. So what I did was took everything out and reloaded it. So
Okay, hang on 1 second and I'll look.
Okay. Allie, you too. Check it out and see. That's what I did. I took everything out. So
Yeah, it works.
Great. Excellent. So that's what I had to do. I just had to reset it. It wasn't anything on my end or your end. They said the system just been overloaded and sometimes things get hung up and that's just what happens. So they just told me to reboot everything and just reset it up. So good thing. It should be 4 attempts in there. I just left it at that. Your highest one is going to count. So I just left it at 4 attempts on that one. Just in case if somebody's got hung up or whatever. The exam 3 topics. I am looking at the test, the part that you're going to have to write out and do. And I am going to tell you exactly what problems are going to be on there, what you need to look for as far as what 7 or 8 things are going to be on there. Half reactions, half life, and I'm going to go over these half life. Let's see what else. The nuclear decay equations. Multi-cell concentration cells, spontaneity chart, half reaction, half-life, nuclear decay equations with the S. I'm looking at everything to make sure. And delta G, delta H, and delta S. What you should see online, I have put up the study guide for the exam. It should be up there. If you look under modules, under exams, study guides, you should see several things. What you should see is one is the study guide itself, what terms you need to know and all of that stuff. You should see about 4 different worksheets up under there. Those worksheets have answers to them. They put the key in everything. One of them is one of my friends who teach chemistry at another school. She kind of summarized the electrochemistry and half reactions and everything and summed it up into a really nice bow. So that is on there as well, just to help you guys really study for everything. So how the written part of the test is going to go. You guys taking quizzes, you know how the multiple choice part of the test is going to look. You know where the questions are coming from. So make sure you look at those. For the written part, and I'm going to put up here exam topics, and I'm just going to put written. What need to grow? Written. What are you going to have to do? The voltaic cell, let's start with that one. For the voltaic cell and the concentration cell, you need to label. There's going to be a voltaic cell and a concentration cell up there. You're going to need to label. What's the difference between the two? Concentration cell basically has the solution is the same. Solution in different molarities. And you know what molarity means, right? Concentration. If you look in your book, if you look online, you can find the voltaic cells. You can find the concentration cells. Let me grab you guys' book and I can tell you what page it is on. I don't have one up there on my shelf. There we go. If you look on page 858 in your book, put that right there. Not my glasses. Page 858 in your book. This is page 858 in your book. For this one right here, for the voltaic cell, let me just link those two together. Your voltaic cell, you will find it on page 858. You'll need to label it, label the diagram, and you're going to need to be able to put the anode, the cathode, zinc, copper. There can be different types of voltaic cells. You can see a lot of them online, but you need to label the voltaic cell. It is one in your book. That is one you can just label, and make sure that you do that. So that's for that one, page 858. The concentration scale one is on page 862. And I'm gonna put here page 862 in your book. So you just need to label those, and I'm gonna put label in the middle. All right, now just label those. Those are in your book. The next thing is the spontaneity chart. Now, what we talked about with the spontaneity chart, the spontaneity chart is kind of and is connected to delta G, delta H, and delta S. Those two are connected. What I'm saying is, what is delta G? If it's negative, is it positive? And does the reaction proceed? Does it not proceed? Let me tell you that I talked about that on a chart, and I am going to go to that. And that is in chapter 19. And I'm just going to find what page that is on so you guys can know about that. Page 830. Page 830 in your book. That chart you need to know. You need to know how delta H, delta S, T delta S, all of that. You need to know that. Page 830. You're going to need to fill out the chart. You got to understand that because on your final exam, there are going to be questions that's going to be asked relating to that chart. What happened if the reaction is spontaneous? What is delta G? Is it positive? If it's negative, what is the sign? And that chart, and that is page 830, table 19.3. So that is that right there. So those two are hooked together. We'll talk more about the formulas in a minute. I'm just trying to get all the easy stuff. So easy stuff that, hey, I can get points on this. Easy. I can do this. I can make sure I pass this. So not a lot of math, but these are the main three that these are easy, grab you, get me points. So that's the low hanging fruit. So you need to know how to do that. All right, so with that, I'm gonna just put that right there. The next thing that is really, really, really easy is this right here, the nuclear decay equations. So let's jump over to chapter 21 real quick. Now these are also, I think some of these were also on the slides as well. So if you got the PowerPoints, these charts are in there as well. So if you don't have your book, these charts, what I'm telling you about, is also in the PowerPoint. So you can go through the PowerPoint. Those are online. Under files, they are there. They are also in the PowerPoint. So whatever I'm telling you is also there. All right. Let's go to chapter 21 and talk about the easy stuff on doing these reactions. Radioactive decay. Page 904 and 905. Page 904 and 905 in your book. Those equations are there. What I am going to do, since these are the easy things, I'm finna do some equations related to this. We did some there, but I'm gonna do a few more on the board because it was a few that I didn't cover, or I want to make sure that you guys understand. It's really simple add and subtract math. It's nothing really hard. The main stuff that's going to be a little bit hard is maybe the half reactions and then solving for delta G, delta H, and delta S. So we'll talk about those in just a minute, but page 904, 905 are those. And I want to give you some simple equations that you guys can do. So we're going to look at that in just a minute. Let me pull up a few. And then we'll talk about half-life. All right. So with that, I am going to erase these numbers, or I'll erase this so we can make some room to do some problems real quick. We still leave that up there. All right, so let me write in another color. All right, so what I want to look at is the nuclear decay equations. So let's just say I want to do a simple one. Carbon 14, we talked about carbon 14 dating. So if I write 14 over 6 carbon, I want to know what it is going to yield. So let's just say I am going to get, and I'm going to leave this blank, and then I'm going to be plus, and then I'm going to put 0 over -1 e. That's for the electron. Now, what I am going to want you to do is to tell me, one, it's two parts to these equations. One, what is missing? And then two, the type of radiation. Basically, what type of equation is it? So with this one right here, what is missing here? So if we do the little addition, 14 is still at the top. So that's going to still be 14 because that's 0. 14 plus 0. So that's going to be 14. We got a -1 over there. So -1. So 6 plus a -1 will give you 7. So that's going to be 7. What you need to do is look at your periodic table. And if you look at your periodic table, you should get N. So that's what you should get. Now, what type of radiation this is? This should be beta. So I am going to ask you questions like this on the exam. So you're going to see it set up. And then what you're going to see up here at the edge of it is what type it is. So I'm doing it as simple as that. Every single one of those alpha, beta, gamma, positron, electron capture is on the exam. So all of those. So on page, I'm going to put it down here, page 904, 905, that's where you find all of them. They also in the slides. You need to know what is missing and the type of radiation. So those are two parts that you're going to need to do. All right. So with that, let me see if I can do some more for you. All right. I want to do one more. I'm taking some of these actually right out of your book. So I am just flipping through the book and finding some of these so that you'll know how to do those. All right. So I'm going to do possibly one more so you guys can see it and understand. And I want to do one with electron capture. I want to do. All right. So all right, so let's do one that is I want to do one that is okay. Yes, let me do one that is that. Just trying to figure out which one I want to do. Oh, let me do one that is not actually on the test for you guys to make it easy. Okay. I did put one on there that deals also with the neutrons. So let me do this one. 239 94 PU. Plus 4, 2. So this one right here is a helium. So 294. So this one is alpha decay. But sometimes even with alpha decay, you look. So we're gonna make sure we got 239 plus 4. 239 plus 4, we got 242, 94 plus 2 give us 96. We just want to make sure that is correct. So that's an alpha one. And then so that's one. And then I'm going to show you, sometimes I talked about in the PowerPoint. So this is alpha radiation right here. So this is alpha. Now, this is called, instead of alpha radiation, this is alpha bombardment. So what you're doing is you bombarding it with alpha, and then it makes a new element. So this is alpha still, but it's alpha bombardment. So just as long as you put alpha on there, I'm fine, because you see that right there. Now, but there are some other things that can happen. So I'm going to use this element again, and I'm going to show you what else can happen. Sometimes when you do the bombardment, you have to do that more than one decay. So let's just say we do this. So you can have uranium. Now uranium can go, just keep on going. And so you have 238, uranium 92, and then you can have this right here. And then that can give you 239, 92 uranium. So you can have that. Now, what can happen to that? That just added a neutron. That's what they did. They bombarded it with neutrons. They added a neutron there. But what else can happen is it can go down to beta 2. What can happen is it can go from here. I'm just going to put an arrow here. And then it can go to 239. 3. And yep. And then that one will eject beta. So that's 0, -1, and then it can do that. So it can go from that out the top, bombarding it with neutrons. you get uranium-239, then what can happen is you can bombard it with beta, and you can bombard it and get beta, so it'll emit beta radiation, and yes, it can still break down more, where it can get 239.94. So it can do all of that. It can break down. Am I gonna put one on there that hard? No, I'm not. I'm just probably gonna put one with probably this step and maybe this step in there together. That's it. That's as complicated as I'm gonna make that. So alpha, beta, positron, electron capture, all of that will be on the exam. Look on page 904, 905. You will see the equations there. This is not hard. This is the simple and easy math that you have to do. All right. So that is that with that. Now, what I loaded online, let me step over here to my computer real quick and see, can I share the screen with that? Trying to see if I can share this one screen. It won't show it. It don't show it. Nope, it don't. I'm gonna just go back to my camera. Okay, so it won't let me show it, but I was trying to pull up. Oh yeah, here we go. It does let me share. All right, right here, and I'm gonna make it smaller so you guys can see it. On the screen, I put a practice worksheet on there. Now, that practice worksheet is basically decay reactions, balancing the reactions, and everything. Most of this is alpha, beta, and gamma. So the answers are there. Make sure that you go through and work through these sheets. This will help you. Most of what is going to be on there is alpha, beta, and gamma, but this should help you. Now, what else is on there is what we call half-life. Now, what I'm going to look at is half-life problems, and so that is there. Now, this is under files. If you go to files, if you go to modules, this worksheet is there. It's review of nuclear. It is there. Go pull that up, because I'm going to go back to the board and I'm going to work a couple of these problems for you. The answers are already there, but I just want to show you how do you go through that and do those. So it's quite a few of these. So it is easy to do. This is not anything hard. So let me pause the share. And I'm gonna go back to the board and actually show you half-life. So if you have any questions on this, on the radiation, I am usually up until about 10 o'clock. It just depends. My boys, their schedules are way off, and it's crazy with them being at home. But if we have to do some really late night study sessions, just let me know if you want to be up that late, so that I can be up. I may have to drink some coffee or some tea, and you guys know I don't like drinking coffee, but if I have to help you guys, I will. So let's look at some of these half-life problems. So we don't went over the nuclear decay reaction. Voltaic cell, you should know. Concentration, you should know. It's easy. Spontaneity chart, great thing. The decay equations, those are easy. The next thing is real easy is half-life. Half-life is real easy because the type of questions I'm going to ask you is very simple. Let me move this out of the way for just a moment. Okay, so on that worksheet, the first question, if a 25-gram sample of nitrogen 16 undergoes 4 half-life, how much of a sample will remain? Half-life is just what it says, half. So basically it's saying is, how long does it take to get to half of that? How many half-lives or how much is left? So you got 25 grams of nitrogen 16, that's what they're saying. Let's see, that is 25 grams of 16, 7, nitrogen. And they want to know how much is left at home. How much is left after 4 half-lives? Simple, easy. So you start off with 25 grams. That's the original. So that's what you start off with. Your first half-life is very simple and easy. Let me grab a calculator. And even for this one, you don't even need a scientific calculator. I'm gonna grab just my phone right now. My other calculator is dead. And this is simple and easy. I'm gonna turn on my calculator. Calculator. You only divide 25 by 2. 25 divided by 2 is 12.5. That's the first half-life, 12.5. So that's the first half-life. The second half-life, you divide that by 2. You get 6.25 grams. That's the second one. You divide it by 2 again. That is 3.125. That's the third half-life. And then the next one, you divide it by 2 again, and you basically get 1.5625 grams. And you guys, that's basically it. Nothing hard about that. Very simple, very easy. That is what you do. Are there other ways you can calculate half-life? Yes. How many days? How many hours? Let me go over a few of those with you. But this is one of the simpler ones that I will put on the test. Okay, so make sure how much is left, how after however many lives, half-lives. So it'll probably just be it may be 4, it may be 3, all of that. Now, especially when it comes to you guys that are going into medicine, when it comes to like certain treatments, cancer treatments and all of that, it may take a matter of hours. Some medicines stay in your body for a few hours. My normal people that babysit my kids when they can't go to daycare, she's going through radiation. And so normally the kids would be with them, but because she's going through radiation, I don't want my kids around her because the radiation still be in her body for a couple of days. So I don't let the kids go around her too much. Even at a time of social distancing, I was staying away from her. We would just speak out the door, out the car because of the radiation. I wouldn't let the kids be around her because of that. So very simple with that. Let's look at a few more of those problems. And I want to see if there's one on there that is really hard. So I'm going through. Let's look at number 6. So another easy one that you will see. I'm going to erase this. Another easy one that you will see. You can have basically iodine 131. That is one that my former babysitter used. That's what she's on. Iodine. Let me make sure. 131. Okay. The half-life of that. Half-life is 8.10 days. So she's using that because she got some thyroid cancer and stuff. So iodine is one of the main ones that they use in medicine. So that's why I'm not letting the kids be around her, because it is literally don't go down to half. So she gets that approximately every 7 days. So once a week she get that treatment. So the half-life of that is about 8.10 days. Now, how many half-lives? So let's just say if it's 24.3 days, they're asking how many half-lives? How many? So the half-life is 8.10 days. How many half-lives would it go through in 24 days? Let's just say she stopped treatment. And we want to look at this 24 days out. What would happen? How much medicine is still in her system? So we're going to look at that. It is very simple. You just take 24.3 and divide it by 8.10. And that is just as simple as that. That is how much math you're going to do. Now, one of the things that I'm going to give you some hints. Make sure that you know how many days are in a month. And I'm not saying, I'm just letting you know, because some of the questions may ask that. Hours in a day. Basically, no time. No time and how it breaks down. So how many days are in a month, hours in a day, minutes, hour, seconds. because some of the questions that I may ask you may be based on hours. It may be based on minutes. Because some have lives or some medicines, when they give treatment, may be shorter. So make sure you know time and understanding. And I know people do, but sometimes we just, we don't do that all the time, or it's just second nature. And then when you take it a test, it'll kind of go like, oh, wait a minute, I don't know what that is, or if you need to jot your memory. Make sure that, just make sure you have that down somewhere, or just write that down so that you'll know. You will see this when it comes to half-lives. I may ask you how many hours, minutes, or something like that. So this one, how many half-lives, we just did the days and just divided days because those units are the same, but you can divide it into hours and stuff like that. Because it could have said how many half-lives, I could have said how many hours that add up to anything like that. So I don't want to catch you guys off guard. I just want you to know. Let's look at a couple of more, and then we're going to get to the hard stuff. So one or two more on this. Okay. Let's see. All right. We also will have years too. This sheet got a lot of problems on there. I want to look at, let's see, number 7 and number 8. So it says the half-life of hafnium 156 is 0.025 seconds. So let's just say we have (156) half-life. And some of them is really short. Look at this one. This one is only about 0.025, and it is seconds. Now, what it says for that question is, how long does it take for the sample to go to 1/4 of the mass? Now, when you think about 1/4, you're doing half-lives. 1/4 breaks down to 1/2 times 1/2. 1/2 times 1/2 gives you 1/4. So that's just simple math. Nothing strange about that. So 1/2, 1/2, 1/4, that is 2 half-lives. That's what that is, 2 half-lives. So with that being 2 half-lives, only thing you do is, you know that's 2 half-lives. You take 2 and multiply it by 0.025 seconds, and you will get 0.05 seconds. So like I said, simple, easy, not trying to make it too hard, but some of these questions are going to be reflective of what I'm going to give you on the part that you guys have to do. All right, and then let's see. Pay close attention to number 8 on that worksheet. Number 8 is a good one, and I know I put one similar to that one on the exam. Pay close attention to that. Really close attention to number 8. Number 8 basically says potassium 42 have a half-life of 12.4 hours. So that's why I say no time. So potassium 42. 12.5 hours. Life, 4.5 hours. I'm gonna put an S on there in a minute. So let's just say if you got 848 grams of that sample, and then you want to know what's the half-life in, what did they say? 2 days and 16.8 hours. 2 days, 16.8 hours. So they want to know how long, what will it take for that to break down? So the question is, we need to know how many hours that is, because this is an hour. We need to put all of this in hours. So 2 days, 24. So you got 24 plus 24 plus 16.8. So if you add that up, you should get 64.8 hours. Then you take 64.8 divided by 12.5 hours. And then you should get approximately about 3 half-lives. Now, you get 3 of them. That's the magic number 3. Now, what you got to do with that 848? Simple. Divide it 3 times. So, something very simple. That's why I say the math on these, they are not going to be that hard. That's why I'm going over the simple stuff first. So, let me clear this out and do 848 plus, divided by 2. So, the first half-life would be 424 grams. The second half-life would be divided by 2, would be 212 grams. And then the third half-life would be 106 grams. So you're going to be left with 106 grams after that 2 days and 16.8 hours. All right, so again, Ote Excel, pretty easy. Label, concentration, that spontaneity chart, pretty good. Nuclear equations, pretty good. Half-life. So majority of this is pretty simple. So let's talk about half reactions. What I did online to help you out on this test, I put a sheet up there that have all of the half reactions on there for you. So those are on there. So I'm gonna pull up that sheet. That sheet have the answers on there on how to do your half reactions. So that's the next thing I'm gonna go over. Try to make this as simple and as easy as possible. Okay, so study these worksheets. Those will help you. I gave you guys some worksheets online as well. So that will help. All right, so let's take a look at, we haven't went over half reactions in delta G, delta H, and delta S. Those are the harder things that we need to go over. Let's see here. Nuclear, okay. Let's see what else I have. Okay. All right, I am going to do another screen share. Now, what you see here is a worksheet on oxidation reduction reactions. Now, with that, there are oxidation rules. Those are listed in your book. These are a few right here. Elements have an oxidation number of 0 because they're in their original state. Group 1 and group 2 has an oxidation state of 0. Group 1 has an oxidation state of +1. That's what I told you. Have your ion charges chart. Make sure you have that because the charges on your ions are normally your oxidation numbers. So you need that. Hydrogen is +1 when bonded to group 1 or group 2. When it forms hydrides, it is -1. When it forms a oxygen, usually it's -2. But when it forms a oxygen single bond, it is a peroxide, that's a -1. Fluorine is always -1. Now, other halogens, chlorine, bromine, the rest of those, they're usually -1 unless they are bonded to oxygen. That's why you can get those oxyacids and all of that stuff. Now, if I scroll down on the sheet, it tells you, number 1, assign the oxidation numbers to each of the following compounds. So if you in a compound, you got to be able to assign those oxidation numbers. So what do you have to do? Compounds are what? You guys should know this. Compounds are neutral. Let me write this back up here. Compounds are neutral, meaning that it has a 0 charge, 0. Now, when compounds are neutral, you need to know what's in there for those charges. So, for some of these, what you have to look at is what's going on with each element that is in there. What is the charge on each element that is in there to make sure that it balances out. So what they have is for that first one is basically, let's take a look at CH4. Good on methane. So the charge on carbon is -4. That's the charge on it. Now, you know the charge on hydrogens. They're +1. That's easy because you need 4 of those to balance it out. So if you do this times 4, that gives you a +4. +4, -4 gives you 0. That is what it is. When you assign oxidation numbers, and even when you're looking at a compound, things that have different things in there, you have to look at the charge on the element. That's why I say you need to have your ion charges chart. You need to know your periodic table. All that stuff I had you guys write on your periodic table, you need to know it. That is very important. You got to know that. So with that, that's an easy one. So what I'm showing you is basically easy stuff, easy points that you can get. Now that is for that one. Let's look at the harder ones. So I'm starting off very simple. I'm doing on time now. Okay. All right. So let's look at the ones with chromium in there. So let's look at sodium. So let's CNA. That is 2 CrO4. So what they're going to ask you for is the charge on the sodium, the charge on the chromium, and then the charge on the oxygen. Now, the rules are up there. Oxygen, of course, is going to be -2 because it's not bonded to anything else. Chromium for this one right here should be a +6. And then for sodium, it's going to be a +1. Now, you guys are going like, okay, why or how does all of this make sense? Okay, so with this, you got 2 of these. You got chromium, you got +6, and oxygen, you got 4 of those. So this is times 4. So the -2 times 4 gives you a -8. -2 times 4 gives you a -8. Right here, you got +1, but you got 2 of those. So what is left is you got to figure out what would balance this out. Since this is -8, you got a +2 right here. You got to have a +6 in the middle. If you got any questions about that, let me know. That's what it is. So that's what you got to look at. Sometimes you got to look at what got these subscripts. Do your charges like this. -2 times 4 give you the -8. So look at anion, cation. You know the anion is positive. Cathode, cation is positive. So let me make sure. Cation, positive, anion is negative. And they got to balance out. If you in a compound, you got to balance. This is the whole thing. You got to make sure everything balances. This is what this is all about. Okay, so simple, easy. That's what you're looking at with that. Now, let's get to a few things that can be a little bit harder. Now, some of these can ask you about oxidation states. What undergo oxidation, what undergoes reduction, all of that. Make sure you understand that because you got to be able to tell me what oxidizes, what reduces. Okay, so well, let's see. I'm trying to see what. All right. This is one that I want to look at right here, is doing these half reactions. So what type of half reaction we're going to have on there? I am going to try to keep it as simple as possible. Some of these can get pretty out of hand, as you saw the one that I went over. So you got bromine minus plus Mn for negative. I'm trying to make sure. And you get Br2. That's oh Br2. Oh, so it goes back plus Mn2 plus. Good old manganese. I like that element. Now, what you do is you got to break this down. So let's look at bromine half reaction. Br minus goes to Br2. And I'm going to make this arrow a little smaller because we need to put something in front of these to see how they balance, right? And then you got MnO minus, that's a 4 there, goes to manganese 2 plus. Now, with this, what you're looking at, you got to go here. In order to get this, you need 2 of those. It's simple. It's just like balancing chemical equations. Same thing. So balance the bromine. Bromine is easy to balance. That right there is going to be the tricky one. Now, if I scroll down and look at this, now, what else I have to do is balance this one with the electrons, because the electrons have to come off. So that's easy. This is a half reaction producing electrons. So that's what that is. So you got MnO4 yields Mn2 plus. You got that. And that tells you balance the manganese. That is 1 to 1 right there. So basically this one is 1 to 1. So this is 1 to 1. But the trick is to that is you got to balance the oxygen. So you got to add water. Because it got 4 oxygens on there, you got to add that water. Now, what else got to happen over here is you got to add those 8 hydrogens. And those are H plus that one. And I did one similar to this. There's one on the slides. All right, so this one is consuming electron. So what you got to do is balance the charge by adding the electron. So on this side, you got to really put your 5 electrons. So let me scoot that in. 5e minus. So your 5 electrons got to be added in order to make sure you add up that charge. So why? Because you got to add 5. Because technically manganese has that +7 charge on it. So you got to make sure you have +2, and then you got to add that 5. So it's going from a +7 to a 2. That's a reduction. So that sheet is up there for that. Now, when you do that and balance everything out, you have to multiply the reaction. So everything is up there. You put the reactions together. If you're looking at this, I'm just scrolling down. I have put this online for you guys to work through so you guys can see that. You add that to that side, balance the equations. And so with that, I've put a lot of stuff on here to basically help you with doing some of these. So that's what I have done. So half reactions, you need that sheet so that you know what to do. So this will help you with that. The last thing that I have not went over as much that I want to spend a little bit of time on is Gibbs free energy, delta H and delta S. I'm probably going to try to post another video with just that on there because of time. And I know that some of you guys probably have another class to attend, and I have another class at 9:30. So we will do that. And that's what I want to go over real quick. Let me pause my share for a moment and go to another share. All right, let me see here. I'll close that one out. The one on electrochemistry, that sheet have some, and it talks about the galvanic and all the cells and stuff. So it gives you some definitions and everything. So make sure you take a look at that. Let me see what else I can do real quick. So let me share. Share screen. All right, with this particular sheet right here, this is the standard reduction potentials right here. This right here have everything on there that you need to add the electrons and all of this stuff. It may be a question on there on your test is most likely going to deal with either zinc, tin, or silver, most likely silver. So if you see ones with silver on it, that's what you're going to be mostly dealing with when it comes to the half reactions. This is a sheet, this is a reference tool, so you will need that. The last thing that I do want to talk about, and so we have went over majority of the half reactions. Like I said, I am trying to keep this as simple as possible, so I don't went over most of this. The last thing is how delta G, delta H, and delta S is related. Let me erase this, and then we're going to go back to that. All right, let me get in your book, and we're going to talk about that in just a minute. And like I said, I may just put up a video on a few of these right here. So in your book, and I am going to pull this chart. It is Appendix C, 1088 to, so 1088 to 1091. You will need for this part, Appendix C, and this is on page 1088 to 1091. So on that chart, it got thermodynamic qualities for substances at room temperature, which is 25 degrees Celsius. Now for that, you got delta H, delta G, and S. Delta H of S, you got S and delta G. That is the chart you need to use. Now, with that, how are some of these related? What is the deal? Let me flip back to the chapter real quick. If you look on page 837, 838, those are all the equations. So delta G, delta G is equal to, and that equation is delta H delta H minus T delta S. All of those equations, but this is the main one that you need to know. Now, with this, you got your delta H's, your T delta S's, your temperature. This is at standard temperature. Now, I'm going to probably put that in the equation and say at 298 degrees. If you see 298 Kelvin in the problem, you know that you need to use this chart to get all of your information. Now, for that, you need to know about what is reversible, what is not reversible, all of that. Now, what type of problems I am going to put on there? Let me see. Let me see what time it is. Oh, I'm gonna have to stop in a minute. What I'm gonna do is I'm gonna have to stop here. That's the only part I haven't gotten to. But what I'm gonna do is I'm gonna probably do a video to teach you guys about this part right here. So we went over everything but this part. And so you may see a 10 to 20-minute video on this, because this is the one that these are going to be a little bit harder than your normal problems, and it's just that I'm going to run out of time, and I know I got that other class coming up. But again, let me just do a quick review of what we have went over already. So you pretty much should, with everything that you have done, should be prepared to take the test. Yes, there's one more problem that is on there, but it's plenty of this. This is majority of it is where most of it's going to come from. I think this problem is not worth as much as some of the other stuff that is on there. Those are weighed a little bit more heavy because I got plenty of a few of these on there. I think it's just one of these on there, but there's a few of these on there. It's quite a few of those on there. When it comes to the half reaction, is one of these and probably one of those. It's just one big problem with some multiple parts. But look for a video on that because I want to go over that a little bit more in detail for you. But everything else, the voltaic cell, make sure you label this. I'm going to go over this again. Label. The concentration cell, label. The spontaneous chart, know the signs for that. Half reactions is just one. If I have enough time in the other video, I might post another one up. Half-life, easy breezy. I told you, no time. And then just know it goes by 1/2. That's pretty much it as far as half-life goes. There is an equation associated with it. You can solve for K and all of that. Study those worksheets. Nuclear decay, those are pretty easy equations that I went over. So most of the topics, like I said, know this, have the appendix. I may do a video to show a few problems. In Canvas, there is a folder that says worked examples. Is in there for each chapter. There are questions in there that are already worked out. Look at those too. So you have that at your disposal. Like I said, send me an email if you got questions or anything like that. I'm going to try to do a video. My biochem class doesn't last long, but I want to do a video to explain how to do some of these problems and what I am looking for on the test. The part 2 of the test will probably open up. The written part will probably open, I'll say Monday night. I'll open that Monday, so you'll have a little bit more time to work on it. The multiple choice part will open up all day Tuesday. Now, Tuesday, if you have questions and if you need me to go on Tuesday for just a little bit in the morning to go over some more stuff, even then I might spend some time on that problem. That'll be fine. Everything is due Tuesday by midnight. So you're going to have a little bit more time on this because you got to write this out. I'm just only opening up, and I may have it open a little bit longer. for that, depending on how people, I know people are working too. And so, but you will have this will be open a little bit longer for you to get that done. But know that the multiple choice part, you only have the time in class. When you sit down and take it, you take it, that's it. Like I did the last one. Let me end it right here. Like I said, these are all the topics for the written part. It's going to open Monday night. All day Tuesday is due at midnight. If you need me to come on, email me, let me know. I can come on that Tuesday morning for a few minutes to give you some encouragement, because it's going to be an easy test. I'm not trying to make this hard, you guys, because after Tuesday, the next 3 to 4 times we meet, we are going to review for our final. That's what we're gonna do. I'm gonna look at what topics are on the final, and tell you how to study, what you need to look for. If you got your study guide, we're gonna look at some of the questions in there and everything like that, and how the questions are going to be set up. Yes, I am making that exam. With that being said, making that exam, the question's gonna look like they're on a standardized test. So if you look in that book, look for those questions. And then I'll go over how it's gonna be set up and how those questions are gonna look. I gotta go, you guys. It's been fun. Like I said, I'll post a video. I'll even come on Tuesday for a few minutes just to go over more of this right here. But I'm gonna also post a video so that you guys can have that. You guys got plenty of stuff to look at. Go study, stay safe. I will see you guys on Tuesday. Good luck on the test.